Am I audible, sir?
Yes, sir, you are audible, sir.
Okay, thank you.
So very welcome to all the participants and their experts in the faculty development program on smart building design towards net zero, organized by Department of Mechanical Engineering and Department of Architecture and Planning at NIT Patna. And we are honored to welcome our experts, Dr. VSKV Harish, Assistant Professor in the Department of Electrical Engineering at Netaji Subhas University of Technology, Dwarka, New Delhi. Dr. Harish will be delivering a session on the highly relevant topic, occupant comfort-centric control of smart buildings. And his expertise in smart building system, occupant behavior modeling, and intelligent control strategy will offer a deep insights into how comfort, energy efficiency, and automation interact to shaping the building and the future. And now I call Dr. Subham Meena, sir, to briefly introduce the expert to the participants. So Subham, sir, over to you. Please introduce the expert.
Thank you so much, Ravi sir, and good morning, everyone. It is my pleasure to welcome our next speaker, Dr. VSKV Harish, Assistant Professor in the Department of Electrical Engineering at Netaji Subhas University of Technology, Dwarka, New Delhi. Dr. Harish holds a PhD from IIT Roorkee and a gold medal in NE for the MHRD fellowship. He also completed a postdoctoral fellowship at the Terry School of Advanced Studies, where he worked on a Netherlands-funded project focusing on smart grid solution for rural India. His research spans smart energy systems, building automation, and control strategies for energy optimization with over 1,600 citations to his credit. He has received Best Paper Award uh, and multiple international travel grant and twice nominated for Young Energy Researcher Award at the World Sustainable Energy Days in Austria. Today's Dr. Harish will speak on occupant comfort-centric control of smart buildings, offering insights into how smart technology and control algorithms can enhance energy performance while maintaining user comfort. Please join me in warm welcoming Dr. VSKV Harish. Thank you so much, and over to you, sir.
Thank you, Subham
Thank you,
Meena,
sir.
sir, for briefly and nicely introduce our expert, Dr. VSKV Harish. And we are delighted to have you with us, Dr. Harish, and look forward to an enriching and interactive session. Over to you, Harish, sir.
Yes, sir. I can share my screen now, sir.
Yes, sir.
Just a second, sir. Share. Advanced. Screen. Sir, can you confirm, sir, if the screen is visible, sir?
Yes, sir, it's visible.
In the slideshow mode?
Yes, sir.
Okay. Thank you. Thank you, Professor Ravi, sir, and thank you, Professor Meena, sir, for the introduction. A very good morning to all of you. And congratulations to the Department of Architecture Planning and Department of Mechanical Engineering to hold FDP, which is not only interdisciplinary in nature, but in multidisciplinary in nature. And interestingly, I really want to put forth this point that the two organizers, one is from the Department of Architecture Planning and one is from Department of Mechanical Engineering. And the presenter before you, as you can see from the title slide, is from the Department of Electrical Engineering. So I hope all the audience and every one of us is getting an idea that when it comes to net zero, energy efficiency, demand response, thermal comfort, occupants comfort, it is necessary that every researcher would need to have a interdisciplinary and a multidisciplinary approach rather than just looking only with objectification to their own bachelors of engineering or bachelors of technology. Just wanted to put forth before I start. For the next hour or so, my focus will be deeply on the occupant-centric control of building energy systems. I'll just cue you in what I really meant by this. What I really meant by this is uh, building energy system. We will clearly define building energy systems. Building energy systems are those systems or processes, or it can be an hardware equipment, which is responsible for the energy usage. Okay, that means any system whose energy transfer or energy usage can be quantified, measured, and can be built upon. Build means you can put a tariff to it, you can put a price tag to it. Comes under building energy system. Okay. Now, if you majorly see the systems, again, that would depend upon how smart your building is. We will also see that a particular building, if incorporated with information and communication technologies, and a user or a building owner or the building energy manager can regulate or can control certain devices remotely, so that in all order you are getting a smart usage of building, is called a smart building. Okay. If you will see the IEEE standardized definition, or even you go through Oxford dictionary or a Wikipedia definition, smart building definition में energy efficiency का concept नहीं आता है. If you technically objectively you see the smart building definition, you will get a large amount of fancy words such as information technology, ECT, communication technology, but very less, or I think not at all, is being talked about energy efficiency and energy conservation. Okay, so this is one part. If you talk about energy efficient buildings or green buildings, energy efficient buildings are, I am giving you the definition of which is followed through International Energy Agency. The energy efficient building is nothing but a building whose complete usage of energy annually is equal to the export and the import basis, so that the net usage is zero or close to zero. Here they don't talk about smartness. Energy efficient buildings definition don't talk about information communication technology. So interestingly, people, chemical engineering, mechanical engineering, architectural planning, all those who are working on energy efficiency, electronics and communication engineering, information technology, computer science students, and electrical students who are working on smart buildings, they can fill these gaps. That can a smart building incorporate the energy efficient and energy conservation technologies, of course, through demand response also. And at the same time, if for a design perspective, if comes under architecture and planning and operational perspective, can there be a certain amount of renovation that can be done in the existing building energy systems through usage of ICT? So this is what will be the major focus of my lecture, or major focus of my topic. Let us first try to understand that why is there a need for occupants comfort centric control or occupants control. I'll give you an anecdote. There is one small request I have from all the participants and organizers also. If possible, during the course of presentation, if at any point or at any slide, you think that there is a point that can be asked, or you have certain questions or certain queries or certain point of discussion, I sincerely request you to interrupt me then and there, so that we can have the discussion over that period of time or at the end of the presentation. But if you want to interrupt me, you can interrupt me then also. Right. Coming back to the concept of OCC or occupants comfort centric control, I'll start it with an anecdote. What happened with me? मेरे साथ जो हुआ, I'll start it with you. As Professor Meena sir and Ravi sir came up with, just a second, sir, just a second, 1 minute. So what happened was, as Professor Meena sir and Professor Ravi sir said that I also did my postdoc. So my postdoc was developing smart grids for rural India. It was a Netherlands government sponsored project, and the lead project investigator or principal investigator was from the Eindhoven University of Technology, Netherlands. Now, we had a project closure meeting in 2020 January. So the Delhi team went there. I was also one of them. And it was very cold outside. And you can see it, interestingly, it is an educational campus which does not have a boundary wall. हमारे यहाँ तो हर building के हर campus का boundary wall होता है. So it was a free run through or a free go through couple of buildings and an Eindhoven University of Technology campus, interestingly. Second thing is a large amount of people use bicycles. Okay. And now my lead investigator, she's a woman, so she was getting late for a meeting. And that building is an energy efficient building. It has won a large amount of energy efficient awards also. I'll tell you what that building had. The building design, the facade, uh, uh, the orientation was such that you can use as much of natural resources as possible and very less dependent upon the active resources or air conditioner or the load, air conditioning load is heating load. Okay. And it was everything was automatic in nature. Like if there are only one or two people, the elevators or lift won't work. Okay, you will have to consider a good number of people for the elevators to work, or you use stairs. Okay, so it was a very different energy efficient concept, or a very interesting energy efficient concept. Now, coming back to the thing that I wanted to share with you. So there was my principal investigator. She was getting late. She is an environmental enthusiast, so she was using bicycle. So she was getting late. She came, she parked the bicycle in the ground floor. The meeting was on the second floor. As she was alone, she could not use the lift. It was January month. It was very cold outside. So she ran through the stairs, went to her room or her cabin. And because she was sweating a lot, because she did a lot of exercise of running and parking and then being excited also. So she went and she used the thermostat so that the air conditioner could switch off the heating and come to cooling mode. But because it was so automatic in nature, she couldn't do that. So many awards given, a very energy efficient building. But do you really think that it is a smart building? That's what my main focus is. See, try to understand what I'm trying to get here. As an engineering or a planner perspective, one has to give a good amount of decision making capacity to the consumer also. For example, we in electrical engineering, we have a concept of demand forecasting. Now in Delhi, if it is too cold in December, the logic says that there will be a large amount of heating load. But if a consumer wants to switch on the AC, air conditioner, on December 25th, I don't think the distribution company has a right to say no to that particular consumer. You can penalize that particular consumer, but you cannot say that a consumer should not do this or should do this only. That is where there is a need for an occupant comfort centric control. There is a need to understand the occupant's behavior. There is a need to understand the occupancy pattern. And that is what the focus will be. And not only this, not only my anecdote, if you see a large number of what you call it as studies have been conducted, and it has been proved that the occupant behavior has had a very strong influence on the building performance. That can be energy performance, that can be in terms of GHG emissions, that can be in terms of comfort as well. Therefore, it has been a very good focus of scientific research for several years. And several research studies have provided a sound framework, a very tight framework for experimentally or for conducting experiments to study and to mathematically model the different behavioral actions when it comes to this system. Hello, can you see my screen?
No,
Sir?
sir.
someone has taken स्क्रीन शेयरिंग हट गया ना सर, किसी ने स्क्रीन शेयरिंग से निकाल दिया मुझे, मैं फिर से करूं सर स्क्रीन शेयर? कैन आई शेयर अगेन?
Please share with. Please share with.
ओके ओके, 1 minute सर. Is it visible now, sir?
Yes, sir. Excuse me.
Okay, okay. So coming back, so we understood why we required to give the building occupant and to understand the comfort levels to the building occupants also, and not only blindly go for energy efficiency or go for smartness of the building. So there are two things that you can handle. There are two ways that you can handle this, either through at the design phase or during the building operation phase as well. My major focus will be during the operation of the buildings. However, there is a very little guidance given to the designers or the building operational managers on how to apply occupant behavior knowledge and models in a standard practice. International energy, again, I have a sincere request to all the participants and all those who are watching this FDP that all the definitions that we will be giving in this presentation, that I will be giving in this presentation, will come from a particular reliable data source, right? So I sincerely request all the researchers or the budding researchers or research scholars to kindly go through the standardized papers or standardized agencies only, and not only through Google or Wikipedia, right? So coming back, International Energy Agency is one such agency which publishes white papers or publishes public access, open access reports. Every year it publishes an energy efficiency report. As per the energy efficiency report, the total energy usage for a building sector or a building and construction sector is increasing rapidly over time. There are many reasons for it. We understand that there is increase in population, but at the same time, there is an increase in the standard of living also, right? And if you come to major cities in India, Calcutta, Delhi, Kolkata, Delhi, Mumbai, Chennai, Bangalore, you will see that each and every of the city has a certain greater part. Delhi, Greater Noida, Noida, Kolkata, Greater Kolkata, Mumbai, Navi Mumbai, right? So these cities are also growing in nature. At the same time, the buildings are not only, construction sector is not only increasing surface wise, but it is also increasing vertically. So there are a large number of high rise buildings coming up. Now the problem with it is, if a large number of high rise building comes up, and if you are reliable on solar PV to achieve net zero, the load will increase. For example, a 4-floor, 100-meter square building has a particular roof area. In a very similar fashion, a 8-floor, 100-meter square building will also have the same roof area. But the demand for an eight-floor buildings will be completely different and maybe more than double as in comparison to a building which is of 4 floors, right? So we cannot only purely rely on renewable energy. At the same time, we cannot only purely rely on design aspect to achieve net zero. We have to combine all these things, right? So the operations part of the building sector, according to that International Energy Agency report, has said that it contributes, the operations part of the building sector contributes to around 1/3 or 32% of the global final energy usage, and approximately 1/4, 26% of the global energy related emissions. That means you have a very good potential of energy savings, cost savings, and the savings in terms of CO2 emissions as well. Energy efficiency, majorly we measure by using the quantification of energy use intensity or the energy performance index. Of course, it is slowly improving, mostly driven by a large number of technologies which are coming up. policy support from the individual national governments. Like in India, the major policy support comes from the Bureau of Energy Efficiency, which becomes a think tank, which has come from the Energy Conservation Act 2001. Now, this growth in energy, we are growing and we are moving towards energy efficiency and increase in solar PV system. As I told you, so policy support, that is Pradhan Mantri Saur Yojana or Pradhan Mantri, Kusum Yojana, for whatever it is. That means, but that growth is not being exceeded by the floor area growth rate, right? As I told you, the high-rise buildings as well. That means that the total absolute use of energy in the building sector is increasing rapidly, right? And of course, the majority of the policies which are available in the traditional domains for building envelope, HVAC design agencies, but there is still an unrealized potential which is not yet tapped in terms of energy efficiency and smart energy usage, which is exceeding more than 70%. That means एक बिल्डिंग सेक्टर में ही 70% से ज्यादा पोटेंशियल है जहां पर हम लोग अभी भी टैप नहीं कर पाए as compared to other sectors which can be industrial sector, transportation sector or a power generation sector. At the same time, post COVID or Corona, what has happened is a large number of works is not being done from work from home perspective. And large number of standards and labeling 3-star, 4-star, 5-star or Griha ratings or lead ratings were given to the commercial buildings. Now, as COVID came, work from home culture started. Work from home culture is still persisting. So there is a very a very important need to understand the energy efficiency concept for the residential buildings also. The government of India came up with Eco Samhita, right? So there are necessity not only to work towards the commercial buildings, but also towards the residential buildings as well. Okay. Now, if you see on your screen, the snapshot that I have given to you is a complete framework how you can study or analyze the advanced control systems or advanced control strategies for building energy systems or BESs. This includes data collection first, how you understand the building, how you know the functionality of the building, because this is very much important. Why? Because in the same city, for example, in Chennai, it is very important to understand and collect the data in terms of occupant behavior also, because you cannot have a same smart energy efficient behavioral pattern for occupants if the building is a library, at the complete opposite if the building is a gym. You need to understand it, because here the activity of the occupant comes into the picture and dictates the thermal loading for the building HVAC systems or air conditioning systems or ventilation systems, and also to a level lighting systems, right? Maybe you require a very good visual comfort, lux level, illuminosity in a library, and you may not require a large air conditioner load in a library, because in library we don't do heavy activities. But if you come to gym, you may require a large number of or a large weightage on thermal comfort, but less weightage on visual comfort, and a good weightage on indoor air quality or the CO2 concentration in parts per million. There are other comfort parameters as well. You can talk about acoustic comfort or the fire efficiency or the fire usage, right? So data is very much important to be collected. And of course, when you cannot develop a model, or you cannot develop a control strategy or a net zero energy control strategy where every time it is relied upon the model. Because what will happen is there will be modeling errors. The reason being, you always start modeling with an underlying assumption. So you have compromised at a particular concept. At the same time, there can be some human errors. And at the same time, there may be some technology which is being evolved and after a few years, the system on which you worked upon to develop the model may become obsolete. I'm not saying the physics will become obsolete. Physics will not become obsolete, but the approach can become obsolete, right? So you require ML-based or machine learning-based algorithms, which will, for initial few years or few months, learn from the model which you have developed, and then take control decisions independent upon the model, but only upon the learnings it has acquired. Then, after a few years of time, it will again come to the model where after 10, 15 years, you can develop or improve your modeling aspect. That is called as model upgradation, right? So that is where ML-based advanced learning algorithms comes. It can be supervised learning or unsupervised learning or reinforcement learning. These are, I will not go deep into ML-based learning algorithms, but interestingly, you can go through different research papers, which I will show you. As you can see, for every slide, I will have a source here, where majorly it is talking about how much it will learn from the environment in which this algorithm is being put up. And based on that, you will have the advanced control strategies for energy savings, for low carbon buildings, for fire alarm safety, for climate adaptation. Depends upon what is the functionality of the building and what do you want from it, right? There can be advanced occupant-centric control also. This is where my research is majorly being put upon. One of my scholars is working here, but she has just started. But this is one of the applications that I'm really put upon. And here, that is what the results that I will be showing, which I have published in Applied Energy and Renewable and Sustainable Energy Reviews. Here, I open the discussion to all the participants that here you can include integrated renewable energy systems, building integrated photovoltaic systems, building to vehicle or vehicle to building integration, building to grid integration or grid interactive building energy systems, peer-to-peer power sharing or power trading systems can be incorporated in all these. That means, for example, if you are working on peer-to-peer power sharing and trading, that means you are saying that, okay, there are two buildings. One building has a solar PV on a rooftop. The other building, maybe due to weather conditions or it does not have that much of capital investment, does not have a solar PV or has a solar PV of a lower installed capacity, then excess energy can be sold to my peer, to my padosi, to my neighbor, right? Now that excess energy that can be sold to the peer or to the agency can be, in such a way that it takes into consideration, and it is completely automatic and takes into consideration the occupant's comfort as well. So this becomes a very interesting research study as well. So if advanced building energy control systems you can be studied and reviewed in terms of data collection, smart metering, machine learning challenges, and so on. So if you look at the relationships and interdependencies between the indoor environmental conditions or indoor environmental parameters and their impact on the perception and behavior, findings clearly confirm that the occupants' expectations with regard or with respect to the environmental conditions do influence the occupants' interactions with the buildings and their energy systems. And such interactions influence the energy performance of the built environment. So so it is not only that, okay, you have installed LED lamps, LED bulbs in your building, मेरी building energy efficient बन गई. ऐसा नहीं. That was a very decade back thing. Here it is not. I hope if you go through Press Information Bureau, last year Bureau of Energy Efficiency has came up with a notification, gazette notification about the 5-star, 4-star ratings of ACs being manufactured before 2024 and after 2024. So they have given CK that before 2024 or 2022, this is a 5-star AC. Today at 2025, you should consider it as to be a 4-star AC. So that is what I'm saying, because the energy target also becomes obsolete, right? So there are several gaps in terms of knowledge on occupant related topics, specifically in the theoretical foundations of human behavior in buildings. the building's user interfaces, and the different ontologies for representation of occupants in computational applications, means different structures that can be used. So it also became obvious that a truly interdisciplinary or a multidisciplinary approach involving the representatives of physical sciences, engineering sciences, and human sciences is necessary to cover the complexity of this topic, which is a occupants comfort centric control. So one thing that I missed is not only architecture, planning, mechanical, civil, electrical, electronics, communication, CSIT people should work together. Even the social aspects of it is very much necessary to understand the occupant comfort centric control. I hope I have taken much amount of time for you to understand the relevance of why it is important to know occupant comfort centric control of building energy systems. If we come to know how do we approach it and why is it necessary, this thing which we have already discussed, the main question that we need to formulate here is, okay, we understood that yes, it is important that we consider occupants comfort because there cannot be a smart energy efficient control if the occupant is not happy. अगर building के अंदर मैं बैठा हूँ और मेरी लाइट, फैन, एसी, प्रिंटर, लैपटॉप ऑटोमेटिकली चल रहे हैं, लेकिन मैं उससे खुश नहीं हूँ. If I am not happy about it, if I am not happy with the energy systems operating in my cabin on their own, then I will not regard it to be a smart energy control system. So how we can integrate occupants or humans into the energy control loop for smarter building operation? Or in other words, how can building energy systems balance the occupants' comfort with energy efficiency target? This is the major question that we will try to address in this course of presentation. How can we integrate humans into the energy control loop? And how can the building energy systems be operated so that they balance the occupants' comfort with energy efficiency aspect? Traditionally, occupants have an access to interface, remote control, thermostat. That is traditional control. If I can use plus, minus, so I have to use a device which has certain sensors, then a infrared, Bluetooth, Wi-Fi, whatever mechanism, because I hope you know that we can use mobile phones also to control my TV, my air conditioner, if I install a Blue Star app or an LG, whatever it is, right? That means, and understand this, we can use mobiles, my mobile, to switch on, switch off, and change the temperature of this air conditioner. My mobile is connected to the internet through Wi-Fi. So I can develop a HTML cloud page and control and regulate, collect all the data for many years, how I am using the AC in June 9th, on June 9th, 2025, 2026, 2027. How I am regulating it, what is my mind, what is my pressure, how I am here. Maybe there is a CCTV camera, so I can get the access of the activity through the CCTV camera also. To just hold this thought, okay? It is very interesting. So and mobile, we can control the mobile, right? And interestingly, I can have my distribution company, which is giving me the bill for usage of electricity, access my mobile also. Okay. Just so in a traditional control system, coming back to the point, in a traditional control system, the occupants have access to the interface, as I told you, thermostat, remote control, but they are separated from the control of the system. I can only give the command 24, 25, 26 degrees Celsius for an AC system. So the system, the control system may include many components, which will include sensors, that particular interface, and the sensor will sense the outdoor condition, indoor condition, and will give appropriate decision aspect of switching on, switching off, increase the mass flow rate, decrease the mass flow rate, increase the illumination, decrease the illumination, increase the hot water or decrease the hot water, or whatever it is. DSW here stands for domestic hot water. And these are the building energy systems or the building services which the occupant particularly can sense about it. right? Now, this is traditionally how you control a building energy system. Now, if we talk about occupant comfort centric control, here the usage, the behavior, the profile of any individual occupant's preference or a family of occupants' preferences and habits can be developed, and the occupants and their presence can be measured by the sensor, right? That means क्या ऐसा हो सकता है कि एसी इंस्टॉल हो मेरे घर पे और मुझे रिमोट की जरूरत ना हो, और we can, and this is happening, when we say Alexa, switch on my air conditioner, or Alexa, open the window blinds, or Alexa, switch on the TV. I'm not using remote control, but I am really using only one particular device which has the access of different systems that are being installed in my home. And I call it as a smart home concept. Can we make exclusively for an air conditioner system or a lighting systems or domestic hot water systems, which are traditionally dependent upon occupants? Not only individual occupants, but a family also. That is the beauty of machine learning algorithm. It can sense a pattern not only for individual occupants, but a span or a group or a community of occupants also. So this OCC, occupant comfort centric control, becomes a very broader term that describes the control aspect or the control mechanisms that will enable the occupants to make the changes to the building systems and internal condition based on their own preferences and priorities. Otherwise, what used to happen? Smart building to bana doge aap log. Building ka energy, see, building once designed, small renovations can be done, but those are capitally intensive, right? We should understand this. Second thing, that if you make everything automatic and it is not in the hands of the occupant, then also it will not be considered as smart, as I told you. Now, you may argue that if the occupant is mismanaging the energy systems in the building and is not going towards the target of energy efficiency, you penalize it. You penalize that particular occupant, you penalize that particular consumer. And that is what is being done in electrical power systems also. That means the OCC systems, the occupant comfort centric control systems, rely completely, not completely, but rely heavily on occupants' behavior, their direct interactions with the systems, and they develop user or a consumer or an occupant definable programs to understand the preferences and thereby adjust the indoor environmental conditions through set point control of HVAC systems, lighting systems, or DHW systems. So it becomes very necessary or interesting how to do it, how to model the occupants, how to model the occupant behavior. International Energy Agency, I request all of you to go through IEA EBC Annex 66. I'll just show you. I'll share my screen. I think I did not share my screen. I'll share my complete screen here. Now, if you will go through International Energy Agency's EBC, Energy Building Communities, Annex 66. If you go through this, it is an open source. Sir, can you see my Chrome? Google Chrome, is my entire screen visible? Anybody from the participant?
It's visible.
Okay, okay. Now you go through, it is very interesting. If you go through this annex, and you can also participate, you can also collaborate, you can show them your interest, and they work on different research papers. They have different working groups. Now, if you go through this annex is completely dedicated towards definition and simulation of occupants' behavior in buildings, right? So you can see all these things, all what this project is all about, how they are meeting, what will be their next meeting, what is their goal, what are their sub-tasks, how many publications they have published, and what is their collaboration and whom to contact to, everything. Interestingly, you can see that a large number of research is being developed upon the modeling of the occupants. So you will, so that's what I told you, that I will give you the area also from where, or the web page also from where you can get the data. Two papers I read from these NX publication, and it was very interesting because they identified that there is a strong influence through real-time experiments, not through theory, through real-time experiments, that there is a strong influence of the occupants on the building energy performance, and they are developing a, see, universal framework will not be possible to develop. This is the first step, second step, third step, fourth step, but they can develop certain guidelines. So they are developing certain guidelines for framework for experimentally studying and modeling the different behavioral patterns and actions of occupants, and how to implement those in the building energy simulation platforms. You can use any platform. You can use Energy Plus, Transys, Design Builder, or you can go through complete modeling or a programming part of Python, MATLAB, where you are developing the thermal modeling from the scratch. And of course, MATLAB has evolved and they have certain inbuilt libraries for air conditioner systems and how the other systems as well. But there is uh, uh, nowhere to develop a mathematically model or to use equations of modeling of occupants. However, this design and building operation practice also shows that many of these mathematical models do not represent the universal human interactions with the building appropriately enough. Because I gave you an example that in a Chennai, or see, an energy efficient building in Chennai may not necessarily be an energy efficient building in Visakhapatnam, may not be necessarily an energy efficient building in Kolkata, and cannot be an energy efficient building in Mumbai, because all of these may be coastal areas, but the aesthetics and also the weather patterns and the wind patterns will change. So not only it is dependent upon the weather parameters, it will also depend upon the particular occupants and how they are using those building energy systems. So there will be a paradigm shift for modeling of occupants, that in traditionally you only take, for example, if I am the occupant and I want to see my air conditioner, the only thing that I give is plus or minus and give them the temperature reading. And it automatically takes into consideration that for this particular temperature reading of 26 degrees Celsius or 25 degrees Celsius, depending upon how I am maintaining the AC, it will provide me the mass flow rate, if the refrigerant is there or not. But can it also consider that there is a one small device, one small box, which is also controlling the visual comfort, the indoor air quality, maybe the acoustic comfort, that is the indoor environmental quality, IQE actions, and then taking the particular decisions in terms of control. At the same time, we are trying to achieve the energy efficient target also. Please, I really want to put forth here is that working on occupant comfort center control does not necessarily mean that we are not working towards energy efficiency or energy conservation. We are working towards energy efficiency, energy conservation without jeopardizing the comfort of the occupants. Right? That means it is necessary that we ensure occupants' comfort as well as the energy savings. So these two things, occupant comfort assurance and energy savings, becomes the two essential objectives. So it becomes a multi-objective optimization programming problem, and it is interestingly contradictory in nature. If you increase the occupant's comfort, your savings are less. If you increase energy savings, your comfort is less. So we are trying to work on the trade-off, and there can never be a single solution, because it is again dependent upon the occupant. For example, you cannot give me a solution to travel from Delhi to Patna. There can never be a single solution. I can travel through train, I can travel through flight, I can take a bus, or I can use my own vehicle. Depending upon my mood, my comfort, my finance, my luxury, and the time that I want to take to reach Patna. So all these parameters will dictate and come up. I will come up with a solution that I should take a flight. Is the flight at what AM? Is it an early morning flight or an afternoon flight? Depending upon my comfort and my finances. That is me being the consumer or the occupant in this particular aspect. Now, if we talk about, okay, we have to work on occupants comfort-centric control. So we have to mathematically model the occupants and we have to do the multi-objective optimization problem. But how to integrate the comfort levels, especially the thermal comfort level, and how to develop a multi-domain architecture or a multi-domain framework for the built environment where a consumer's perception of control, consumer's perception of comfort is being mathematically realized. So what I'm trying to say is, क्या consumer का social behavior, the mood which I told you, can it be mathematically quantified? There are certain research which is being developed, which is being worked upon, where what can be the primary elements of the multi-domain built environment that is being considered. Now here we can see that, as I told you, how a particular user at what periods of time, because collection of data is very much important. The data is very much important if you want to understand the behavior of the occupants. Unfortunately, in India, I think very recently, in last 10 years or so, we have tried to understand that building is a sector in terms of energy usage. Uh, Maybe 2015-16, NIT Aayog came up with its National Energy Policy report, where I think it was the first time where it was quantified. Otherwise, NGOs, think tanks like TERI, CEW, they were publishing reports considering that building should be a sector and it is accounting for this much of energy usage in India. And still, if you see, it is not very easy to get the data in terms of energy perspective. But if you go through excellent journals like Energy and Buildings and Environment, IGBC, CIBSC journals, Chartered Institution of Building Service Engineers journals, and ASHRAE journal, a large amount of research papers are being published where they are giving the data, where they have collected the data and publishing it for the last 10 years. Nature Energy, one of the excellent journals, published the data of 37 communities, which Harvard Business Community, Harvard Business School, they conducted that particular research. And it was very interesting. And they put on that huge Excel files, CSV files in GitHub. And they understood what is the pattern, how is the usage pattern, what is the age of particular people who are living there, and over the 10 years of data, how their mood is changing, how their usage of energy is changing. Because a 16-year-old kid may use energy very lavishly or exploit it a large amount of time, but that particular occupant living in the same building or in some other building would change its own behavior or perception of comfort. So very interesting social behavioral data has been published. So it is necessary that we understand that how we collect, integrate, prune, analyze, and then give the input to the control system. If you are working on a building energy control system, if you are working on controllers where you have developed some microcontrollers, Arduino Raspberry Pi based or FPGA based microcontrollers, where you are saying that, okay, if someone gives this as the input, this should be output of the air conditioner system, and it is regulated in real time or near real time by this controller. But that controller, if you want it to learn the behavior of the particular occupant and not depend upon the modeling aspect and become independent of the model, so the modeling losses become less and still gives the optimum performance, then the perception of the building occupants is also necessary. So as I told you, when I told you about mood, so these are the psychological needs, say safety and all these needs that occupant considers, and you give the all this data, and you then prune the data, classify the data, and you say that this much of data is important for thermal comfort aspect, maybe PMV or PPD mathematical calculations, that is the predicted mean vote index or a thermal sensation scale or a percentage of people dissatisfied or satisfied or whatever. ASHRAE has a large, if you go through the ASHRAE handbook, you have a large number of mathematical indices that you can consider. PMV is majorly being considered, as other speakers before me may have considered it. And some of the data you will give the classify it to the data that will be used for quantification of indoor air quality. Majorly, it is CO2 concentration of parts per million. This indoor air quality has become very much important after COVID scenario as well, because now the standards are being developed. Very importantly, the standards are being developed where it's not only about how humid or how cool you are keeping the environment, but also depending upon the occupancy, how much fresh air is coming in, and how much stale air is going out or going through the exhaust. So the mass flow rate is that is the air changes per hour, ACH, is also becoming very much important here. And then based on this, you can take the building design decisions, interfaces, active building energy systems, where these majorly can be worked upon the building operation aspect as well. How do you collect the data? One such research paper that I came across where they were using solar PV systems for a building integrated photovoltaic systems, and they integrated it with Internet of Things, that is IoT. Internet of Things IoT, where there were a large number of solar PV systems which were integrated through inverters, and there was a weather forecasting system. So what they did is they were doing two things. Either you do the demand forecasting system where you get all the data and you know that this particular occupants or the occupancy family is using the demand like this, and this becomes a demand pattern. And through weather forecasting, you estimate that in the coming years, this will be your solar PV output. So you do the weather forecasting or the input forecasting or the resource forecasting, and I will also do the demand forecasting. So you multiplex all this and keep the data storage, and that particular data can be analyzed, pruned, and used for machine learning based algorithm, and it is being saved in the cloud. So when it is saved in the cloud, every particular user will be given a username and password, and it for safety reasons, so that that particular data cannot be shared or cannot be used in the neighborhood facility or in the same building, but at the different floors of the buildings. As I told you, how you do the data analysis and data pre-processing is what is being given here. Uh, there will always be errors. We consider that there will be certain errors which we cannot take out, even if it is 100% pure data. For safety reasons, we say that it is not 100% pure data. There is some missing data. There may be some false data. There may be some unnecessary repetitive data. So you do all the balancing, cleaning aspect, and then you normalize the particular technical features, and for every particular features you then do a labeling aspect. For example, you want to cluster certain amount of data and you want to cluster it family wise, age wise, functionality wise, psychological wise, or whatever it is, right? Means, for example, your what you call the research can be for hostels. You may want to implement this occupant comfort centric control for hostel, because interestingly, if you have a hostel of 1,000 students or a 500 students, even though each and every student would be living in the same room for 2 years or 3 years or maximum 4 years, another student coming, it is very seldom that after 4 years another student is coming in and the pattern of usage of fan, air conditioner, or a cooler, or an AC, or a other refrigerator or other systems is completely different. It doesn't happen usually. There will be certain change, I told you. So you can cluster those data. So you can pool those models. And then you do different ensemble techniques for machine learning or neural network based algorithms, where you come up with different neurons or different techniques which you would be using. and then you will apply for different particular results. Currently, for a smart inverter, again, if you'll go through renovations which are happening and go through some advertisements which are coming in the TV also, large number of air conditioners are coming as energy efficient air conditioners, which is inverter air conditioners. So they use solid state semiconductor devices where the compressor speed or the frequency at which the compressor will work will have a particular number of inertia and will not be dependent upon the transformer perspective, and an energy efficient output will come even if there is a fluctuation of voltage and frequency from the supply side. So this is very interesting. So I say that that is the modern air conditioner. So they use two level of controls. One is the PID or a LQR. LQR stands for a linear quadratic regulator control. And there is so this becomes a slave control and this becomes a master control where they use a model predictive control or a multi-agent system. So if there are number of AHUs and the number of air conditioners, centralized air conditioners which are being used, so you can have different slave controls and one master control which is considering into the desired temperature. This desired temperature again can be set through a remote control, can be set through the building manager or a building energy owner, or can be set through the distribution company. That the distribution company is saying that I want to set this. Again, if distribution company is completely controlling this, then it is not an occupant comfort centric control. Okay. Now, so these are the current practices which we are having. So why I have shown you this is because you can develop a MATLAB based model, Energy Plus or Design Builder based model for and do all the energy calculations, loading calculations, and also energy usage and cost saving calculations, considering these aspects. Majorly, we can use transfer function modeling if we are working towards the control aspect. Here in our department, in my room, what we are doing is we are developing a hardware in loop test bed of occupant comfort centric control, where we are considering this as the modern air conditioner control. Again, this is not a traditional control. So my benchmark is not traditional control. My benchmark is in itself is a smart control, which is coming towards the market in the coming years or costly, but today it is coming into the market. And we are developing a occupancy detection. That is, I told you that we will consider the occupant's behavior, and that particular occupant behavior will be regulating this desired temperature. And that's what I have done here. Right? So it is regulating the mass flow rate and also the heat rate at which the building space will be considered. So this will be the space that we are working on. These are the sensors that I will put. This is my cubicle. These are the sensors which I will put. I am already using this 5-star inverter based air conditioning systems. And we will develop a machine learning based algorithm which will learn and observe from the data which is coming from this same ambient condition. This will be my condition from which it will come and save the data. And we will develop. So there is Energy Plus simulations of the building energy systems, and the data will be collected there because Energy Plus gives a very minute and very easy and open source. It's an open source software. Weather data of Delhi is available. So all the occupants comfort evaluation, all of this calculation will be done from the occupant behavior, and occupant behavior is being considered. There is a small, what do you call it, Google form that is being developed. And every day my researchers come and they ask me to fill that Google form. And that Google form takes into considerations hourly or minutely. And if there is some missed data where I have not filled the Google form, the same couple of slides before I showed you how you fill that particular data is taken into consideration. So building energy, so this is a co-simulation which is going on. So building energy simulation is happening at Energy Plus, giving the data to MATLAB. The control strategies, the block diagram, transfer function block diagram will be developed in the MATLAB. So we are working on the robust control where we are using Kharitonov theorem to understand the stability of Routh array and Routh Hurwitz and bringing the zeros are there in the right hand side, but bringing the poles on the left hand side and achieving the desired control action. And then we give the particular decision making to the lighting systems. Here, the lighting, unfortunately, we are writing a project where this is on and off. I cannot change the illumination level, but I want to change the illumination level. So there is a 0 off, slightly dim, slightly dim, average, then bright, very bright. So these are the 6 positions of visual sensation scale, not the thermal sensation scale, but visual sensation scale that we want to work on. Then this particular control strategy will become a little different and little interesting. So these are the parameters which we have considered for our building energy system model. Because I told you that we will be developing the transfer function based model. Those who are not from EC and electrical background, transfer function is nothing but um, since school we know that if you give a time data, so time will be in x-axis and in y-axis there will be a function. So f of t it will be in the y, and it can be a quadratic or whatever curve it can be. If I remove the time, so, and I not do the time domain analysis, but the Laplace domain or a frequency domain analysis. So the x-axis will be something different and y-axis will be something different. So I will not be getting a complete curve, but I will be getting certain points. Using those points, which can be poles and zeros, I can understand the behavior of the system. Whenever I change the location of those poles and zeros or location of those points, I can change the behavior of the system according to my desire. So this becomes easier in as compared to the time domain analysis, where I have to change each and every point of the curve, right? So that is Laplace domain or whatever I was telling about the transfer function approach, loosely. So here there are certain parameters that I have taken as controllable or uncontrollable. Controllable, uncontrollable means for an uncontrollable nature, my control algorithm cannot change the behavioral pattern of that particular parameter. Okay. Controllable, that my control strategy will change. RNR stands for residential or a non-residential application. So again, we have developed the model using thermal electrical analogy for validation perspective. So I have developed the model in Energy Plus and MATLAB and then validated it. So whatever control decisions MATLAB take, it will be valid in nature. So we have used thermal electrical analogy, which says that as heat flows from a higher temperature region to a low temperature region, electric current flows from a higher voltage point to a lower voltage point. So electric current, so every thermal model can have an equivalent electrical circuit model where the parameters are dictated by this analogy of physics, where current becomes heat flow, where heat flow becomes current, and the temperature becomes the voltage, because the heat is flowing from high temperature to low temperature. So the current is flowing from higher potential to the lower potential. So we developed a multi-layer building energy model where every wall is a multi-layered wall. So you have a brick, then you have cement, then you have insulation, then you have certain putty, then you may have a wallpaper. So each and every parameters I have taken from the ASHRAE handbook or the ASHRAE data, and we have developed thermal electrical analogy to develop this model. I have used the one technique, optimization technique. I encourage all of you to go through this paper, which we have developed, published in Applied Energy, where I have used the parameter estimation technique and also the model order reduction technique, where I have used a nonlinear constraint optimization technique to know what should be the value of R1, R2, R3, or C1, C2. Traditionally, I'll tell you what used to happen. Traditionally, you calculate RTH and CTH. This data is given from the manufacturer. Okay. So you calculate the total thermal resistance, total thermal capacitance. What studies used to do is, after calculating total thermal resistance, R1, R2, R3 was equally divided, 1 by 3, 1 by 3, 1 by 3 of RTH. For example, if RTH comes some 1000, so this becomes 333.33, 333.33, 333.33. In a similar fashion, equally divided total thermal capacity, right? But that is not applicable, widely applicable for different types of buildings and different functionality of the buildings. So we developed an optimization technique So we didn't have had the funds for do an experimental validation. So what I did was I took the most accurate model for a wall. So the most accurate model, of course, is an analytical model, but does not make any sense. So I considered a numerical model, numerical solution for that particular model. So I used a central difference scheme where there were partial differential equations from Newton's law of cooling. So we developed it for a multi-layered wall. These layers were 100 in nature. Okay. And for the same system, I developed a 3 resistance to capacitance network. I gave this particular model an input. Same input was given here. The output coming from this model, this is my most accurate benchmark model. The output came from this model is the most accurate in nature. And the output which came from this model is erroneous in nature. So I developed a mathematical function to compare these two outputs as sum squared error, SSE. It is an error index. So my optimization technique became that you have to minimize this error. How we minimize this error? Slowly by changing R1, R2, R3, C1, C2. So my algorithm automatically changed R1, R2, R3, C1 and C2 at each iteration so that the output of this model came as close as possible to the output of this one. The value at which these two outputs were very, very similar in nature, those values are optimal values of R1, R2, R3, C1, C2. This is for one wall. Okay. This is for one wall. That means I request participants, if they're sitting in their cabin or their room, if you look around, you are geometrically sitting inside a cuboid. So you have 4 walls surrounding you, one roof, one floor, windows. Okay. Every wall is 3 resistance, 2 capacitance network. So if I have 6 such walls, 4 walls, one roof, one ceiling. So I will have 6 such 3 resistance, 2 capacitance networks. And if I have windows, I will have 2 resistance, 1 capacitance network because the thermal capacity, because the windows are opaque in nature, so transparency is there, right? So using these algorithms, I'll get, as I told you, for each and every wall, I'll get R1, R2, R3, C1, C2 values. So this is my geometrical nature. So I have considered 2 windows in nature. So every block which you are seeing on your screen, every block which is you are seeing on your screen is a 3 resistance, 2 capacitance. Is a 3 resistance. So this is a 3 resistance, 2 capacitance network. So this floor block is nothing but this network. AW2 adjacent wall 2, second adjacent wall is a 3 resistance, 2 capacitance network. So on, right? So now I have developed a building energy system model. Now I have taken an all seasonal HVAC system model where we have used already defined PID controllers, where the PID controllers are tuned using Ziegler-Nichols method. In control systems, we use Ziegler-Nichols method. Uh, During my PhD days, we took some data from the Indira Paryavaran Bhavan. It is the most energy efficient building in India. It is nothing but the headquarters of MOEFCC, Ministry of Environment, Forest and Climate Change. So we took some data and run the analysis on that particular data. So this is the input which we have given. As I told you, it will be a multi-objective or multi-input, multi-output system. So there will not be a single transfer function, but there will be a multiple transfer functions. So these are the data which we have taken from the weather data file from the Energy Plus, and I have quantified them in Excel. These are the outputs which are coming from the MATLAB, right? So co-simulation is happening. And now we have to optimize, mathematically formulate the optimization problem. So you want to improve the comfort. So the comfort we have taken in terms of indoor air quality, that is the CO2 concentration of air in the building space, visual comfort, that is the building space illumination level in lux, and building space temperature, that is the degree Celsius in temperature. Here, we have used the mass fraction method of ASHRAE, where you integrate the relative humidity into the thermal comfort. aspect. In a similar fashion, I have to maximize the comfort here, and I have to minimize the HVAC and the lighting system. So we have developed. What I have done is at that time there were no GA or PSO handlers in MATLAB, so we did a coding to integrating or develop hybridization of genetic algorithm and particle swarm optimization technique. So as I told you, there will not be one single solution. There will be a Pareto front or a sample solutions. So as you can see here, we did the comfort calculations using that mathematical formulation of comfort, and you got these results from the optimization technique. As you can see, as you are increasing the comfort, this is in per units. So 0.9441 means 94.41% of comfort. So as you are increasing the comfort level, you are increasing the energy usage. So energy savings is getting less. So as I told you, it is a multi-objective optimization technique. And you are getting the better control as well. Here, what I have done is there is one assumption that I have taken or one limitation of my work, which we are working since last couple of years. The limitation here is hour back, I put the thermostat or the remote control at 22 because I just came from the meeting. Now I have kept it at 25. So what I have done here is the limitation which I am telling you, or the assumption which I have taken is, if I am doing, as you can see here, I am doing the analysis for 1 hour, for example. Here I am doing it for 24 hours. I'm just giving you the example. Try to understand. 1 घंटे में मैंने 22 किया, फिर 1 घंटे बाद 25 किया. अगर 1.5 घंटे के लिए चला, if the AC is operated for 1.5 hours, the thermostat setting is 22 plus 25 divided by 2. So I am taking the average, which can be considered as a trade-off, but it is not true to the real time. So right now, so this is not a dynamic optimization which I have used. This is a static optimization. Now, one MTech research fellow is working on where this solid, dashed line is not constant in nature, but it also moves. So this thermostat set point, which averaged came for 16.5 degrees Celsius in the month of June, is not 16.5, but again is a curve. So if it is again a curve, the optimization technique, the solution method which I have used, G and PSO, has to be a dynamic optimization technique. So the optimization problem formulation will not be static in nature. It will have an integration form, integration in nature. Similarly, this I have done for temperature. Similarly for CO2 concentration. Similarly for occupants comfort. Similarly for illumination level and the occupants comfort. So these are the energy savings that I have considered for daily, weekly, monthly, and there is then again, I think I have missed it here. Then again for annual energy savings. And now you can argue here that sir, the savings is very less. Yes, the energy savings is very less. But mind you, that I also want to get your attention. The occupants' comfort has also improved. So you are getting energy savings without jeopardizing the occupant's comfort. So there is a win-win situation for every significant stakeholder. Occupant is the significant stakeholder here. So if we want to integrate the occupant behavior models into building control, there are different type of models which you can work on. One such model came from this International Energy Agency's annex. There is a book also, Occupant-centric building design and operation, where they have used the model predictive control technique. Model predictive control technique means for a certain finite time horizon, the control itself will predict how the model will behave without giving any input to the model, right? So at every time step, it will develop a cost function where it is minimizing the effort which is taken for the control system and also minimizing any modeling error which is happening. So here the building are modeled as a dynamic models or state space form. These are the dynamic models where dot represents the differential equations, right? So they develop a state observer for people who are not from electrical or electronics background, let me take some time to make you understand state of a system. State of a system, loosely you can say that you have a system. A system will have some mathematical parameters. See, whenever you talk about system, whenever someone says system, imagine yourself a block with an input with an output. So input parameters, output parameters, block system parameters. Okay. There are certain system parameters. As you are giving the input and realizing the output, the system parameters are also changing with respect to time. So there are certain f of t, which is a curve with respect to t, it is changing with respect to time. So if you do df by dt, you are getting some maybe constant but a non-zero value. So those parameters who dictate the complete behavior of the system, but they are dynamic in nature, are state parameters, right? Every state parameter cannot be mathematically quantified, cannot be mathematically measured, or the measurement cost will be very high. So what we do is we develop an observer, right? Where it observes or where it says that these are certain observed states of the systems depending upon the output of the system. Okay, so this is what the observer is doing, right? Now, occupant behavior model you have developed. How do you judge if that particular occupant behavior model is behaving properly or not, or performing properly or not? So you develop different performance evaluation metrics for integrating the occupant's behavior. One is the absolute metrics. Absolute metrics are used for data-driven modeling, statistically data-driven modeling. They describe how accurately or often the occupant behavior model is providing the correct prediction. So what you do is, for every data, you do for every iteration, you do a mean average error calculation, and you try to improve that mean average error. So as your iteration is increasing, the error is reduced. Then there is a domain metric. Domain metrics are defined explicitly in the context of human behavior or building energy physics, or the fundamental physics of building energy system. They assess how well a model represents a particular aspect of human behavior, for example, average occupancy duration, so on and so forth. Then there are indirect or control metrics, which are even more specifically designed to characterize the impact of the occupant's behavior on the building control objective. For example, resulting impact on energy consumption and the thermal comfort or overall usage. So the first two metrics, which is the absolute metric and the domain metric, helps to give us a general overview of the model performance. And the control metrics show the actual benefits of the building operation or the productive building operation. So we integrate the occupant behavior models into model predictive control, as already we have discussed here, for set point reference scheduling. That is what we have done in my study, for shaping the constraints and including measurable and predictable disturbances. As I was giving you an idea that how we can integrate this in a peer-to-peer or buildings to grid integration, this is how we do. We develop a power system model, because every building is connected to the grid. So it is getting electricity supply from the grid. Now grid dynamics can also be integrated with this building energy system model. There is no universal architecture or a universal framework for buildings to grid integration. One of the framework for a net zero energy efficient building is that you use a power electronic interfacing to connect it with the grid and take all the data from the smart meters, where you do all the energy storage system data, all the load data coming from it, and we try to develop a building to grid integration architecture. In the coming years, this is what my major scope is, that I want to develop a mathematical tool to evaluate the socio-techno-economic analysis of prosumer-based energy systems, and to assess the energy and environmental aspects of buildings without jeopardizing the occupants' comfort. So one of the major stakeholders, and I think one of the most important stakeholders, are the occupants. That's all from my side. Thank you very much Department of Architecture, Planning and Mechanical Engineering, for giving me the opportunity to interact with you all, especially Ravi sir and Meena sir. Thank you very much, sir. And thank you to all the participants for the patient listening as well. Over to you, sir.
Thank you, sir. Thank you so much. Now the platform is open for the participants. If you have any query, please ask the experts. If you may have any discussion regarding to this research area you want to discuss, so you can discuss with the expert. Hello, sir. Harish, sir, there is a one question from my side.
Sir.
What are the main challenges in modeling and managing the uncontrolled parameter in occupant behavior, sir?
Yes, sir. Sir, very interesting question, sir. Sir, the main challenges is that we have to rely majorly on the sensors. As I told you, sir, either you say the occupant that for every hour or every 30 minutes you fill the Google form, but that does not make any major sense. So you need to acquire certain sensors which will capture the occupant's behavior, the occupant pattern, the activity of the occupant. So the cost is capital intensive, but the sensors are getting cheaper. But if you want to build upon a wireless sensor network, again, that will be an integration of ICT. So it will be a cost intensive in nature. So one challenge is cost. Second challenge is that if you want to capture the data for a larger period of time, as I told you, for 10 years, for 5 years, the sensors have to be very much robust, and proper maintenance and the renovation of the sensors is also very much important. This is one of the major challenges when it comes to the occupancy behavioral pattern. Second challenge is a social challenge, that if you want to capture the data for larger period of time, the occupant himself or herself is also changing psychologically. हम लोग 5 साल पहले एसी को शायद अलग तरीके से चलाते थे, अब मैं खुद उसे अलग तरीके से चला रहा हूँ. So there is a psychological change. So you need to develop some social, scientific, mathematical inclusion also when you talk about the psychological aspect of the occupant behavioral patterns. So there are these two main challenges. One is completely dependent upon sensor. So whatever disadvantages are there for using sensor, all the disadvantages come here. And the second challenge is the psychological changes for a larger duration of time.
Okay, thank you, sir. Participants, if you have any query. So thank you everyone for attending this today's insightful session on occupant comfort-centric control of smart buildings. The DSKV Harish, Assistant Professor at NSUT New Delhi. Dr. Harish provide a deep understanding of smart building system designed to enhance the occupant comfort while improving the energy efficiency. He elaborated on advanced control strategies, including the model predictive control and integration of machine learning and artificial intelligence in intelligent building operations. And the session is also addressed some important for identify and managing the both control parameters, that is controlled and uncontrolled parameters, as are shown in their slides, And these factors play a critical role in achieving an efficient control and smart buildings. So we thanks Dr. Harish for their enriching session and all participants for their active engagement. So thank you all, and we look forward to your continued participation in the upcoming FDP sessions. So
Thank you,
thank you everyone, and thank you Harish sir.
Thank you, sir. Thank you.